Alright, so today we're talking about the quadratic formula. And this should look familiar because you've done this in algebra and likely in geometry as well. But basically, this is another tool for solving ax squared plus bx plus c equals 0. Okay? Now, the first things first, with all of these problems, it's very similar to what we've been doing all along. You must always, capitalizing always, and underlining it too so you understand it's important, be equal to 0 before you can use the quadratic formula. Okay, it always has to be equal to 0 first. So if you look at like number 2, number 3, number 4, we got to get those equal to 0 first. Now number 1 itself is equal to 0, so I'm just going to start with number 1. And it's as simple as this. So we're going to go into it, and we are going to, first things first, you don't have to always do this, but I would identify what A is, what B is, and what C is. Because if I do that, well, then it's just a matter of plugging stuff in. Okay? Because the quadratic formula is the opposite of B. A lot of you see that as negative B. But if it's negative, we got to do the opposite and make it positive, and so on. Plus or minus the square root of b squared minus 4ac all over 2a. Okay? Soak it in a second. You've seen it before. Hopefully you remember some of this. Matter of fact, I remember teaching this in 7th grade, so you've seen this before for sure. Okay? Now, when we get down here, again, if we can simplify this, if we can reduce things, we want to do that first. For none of these problems that's really applicable, but I know that A is 2, B is 6, and C is 1. Okay? Now, if I go to set number 2 up, I'm not going to do number 2 right now, but I'm going to set it up. I'm going to minus 2 to both sides because I need it to equal 0. I can't combine these, so this is 3x squared minus 5x minus 2. So when I identify A, B, and C, A is 3, B is negative 5, and C is negative 2. That's kind of significant. Okay. Now, when I go to set this problem up again, I'm just going to plug it right into there. I'm going to take the opposite of B, which is 6, so negative 6 plus or minus, and I'm going to be very intentional about what I write here. I'm going to plug in 6 squared, so whether it's negative or positive, this value is always going to be positive after I square it. Remember that. Minus 4 times 2 times 1, I've just plugged everything right in like that, all over 2 times 2. Simple as that. Okay. Let's start doing some simplifying here. Negative 6 plus or minus. I've got 6 squared, which is 36, minus 4 times 2 times 1. Well, 4 times 2 is 8, times 1 is 8. You're not going to go like distribute the 4 and do that. You're just going to multiply left to right. 4 times 2 is 8, times 1 is 8. All over 2 times 2, which is 4. Of course, that simplifies to negative 6 plus or minus the square root of 28 all over 4. And now from there, well, 28 we know breaks up into 4 and 7. So I can take the square root of 4. I can't take the square root of 7. We've been doing this for a reason so far. So negative 6 plus or minus, well, the square root of 4 is 2. The square root of 7 I can't do, so I leave it as is, and divided by 4. And then I want you to see that we need to simplify. What can I simplify? Well, what can I take out of each one of these terms? You can only simplify it if it comes out of each of these terms. If that was just square root of 7, I could do nothing to this. That would be my answer. But because I can take a 2 out of every single one of these, I'm going to take a 2 out of that, I'm going to take a 2 out of that, I'm going to take a 2 out of that, and my answer here is negative 3 plus or minus the square root of 7 over 2. And that is good enough. The plus or minus accounts for the two answers. This is negative 3 plus the square root of 7 and negative 3 minus the square root of 7, both of them over 2. Okay? Let's take a look at number 3. I'm going to have you guys try number 2 now that I set it up. By the way, that's equal to 0, sorry. Here, again, I could bring the 2x squared over here, or I could bring these two terms over here. I always like to have x squared positive, but it's not wrong if you move the 2x squared over here and make it a negative 2. Okay? So what I'm going to do again is I'm going to add 6x and add 7 to both sides. So these cancel and these cancel, and I get 0. And everything else just gets written in there. Okay, so I've got that so far. Now again, what's A? 2, B is 6, C is 7. It's not always positive values. You can see that up on number 2. We got some negatives in there. And I'm just going to plug it in. So I've got negative 6 plus or minus the square root of 6 squared minus 4 times 2 times 7 all over 2 times 2. Again, I'm going to go through the math. Plus or minus the square root of 36 minus 4 times 2 is 8. 8 times 7 is 56 all over 4. Negative 6 plus or minus the square root of negative 20 over 4. And again, we're going to break this up, but now hopefully you recognize from the last couple of days assignment and the quiz you took yesterday that this negative means I got to have an I in there. So I'm going to break this into 4 and 5, and I'm just going to put negative 1 kind of out here so I remember it. So again, I've got negative 6 plus or minus the square root of 4, which I can do, which is 2, the square root of negative 1, which is I, and the square root of 5, which I can't do. And just like the last problem, I can take a 2 out of all of these terms. I don't want to worry about what's inside. I can't do anything with what's inside compared to outside, okay? So I got a 2 out of here once, a 2 out of here 3 times, and a 2 out of here 2 times. And I get negative 3 plus or minus I square roots of 5 over 2. And that, again, is my answer. Now, I'm going to tell you that 2 and 4 are going to work out a lot nicer, okay? Let's work on it. I've already started number 2. I've got my A, B, and C. I'm going to plug in B. So the opposite of B, so negative, negative makes it positive 5 plus or minus the square root. Again, I'm going to put negative 5 in parentheses, minus 4 times 3 times negative 2. There's a lot to this one now. We've got 5 plus or minus. Negative 5 squared means negative 5 times negative 5. And again, like I said a few minutes ago, this number is always going to be positive because you are squaring it. Then I got to look at what else I got here. I got negative 4 times 3 is negative 12 times negative 2 is positive 24. So that becomes plus 24 there because of this negative times a negative. Okay, all over 6, which is 5 plus or minus the square root of 49 over 6. And that's kind of nice because we can take the square root of 49. Of course, that's just 7. So I'm going to keep writing that over here. 5 plus or minus 7 all over 6. What does that mean? Can I reduce that? Yes, but let's just take the easy thing here. This means 5 plus 7 over 6, and it also means 5 minus 7 over 6. Okay, well, that's 12 over 6, which is 2. That's negative 2 over 6, which reduces to negative 1/3. Not 3, not negative 3. The 3's on bottom because I take 2 out of there and 2 out of there to get to that. And that, ladies and gentlemen, is our 2 answers. You guys try number 4. The first thing I would say is make sure that these go to the other side by doing the opposites. Identify your A, B, and C and plug them into the quadratic formula. Go ahead and push pause and try it on your own. So again, the opposite of negative 8 plus or minus the square root of negative 8 squared minus 4 times 3 all over 2 times 4, which is 8 plus or minus the square root of, again, that's always positive. Negative times a negative is positive, and then 64. And then I got minus 4 times 4 is 16 times 3 is 48 all over 8. 8 plus or minus. Now what a lot of you are going to want to do here is try and cancel out these 8s. That's not how it works. Remember, it has to come out of all 3 terms, and we don't even know what this is yet. Well, actually, I kind of do. That is the square root of 16, which reduces to 4. Kind of did 2 steps at once here. All over 8, which again is 8 plus 4 over 8 and 8 minus 4 over 8. That's what that plus or minus again means. So I get 12 over 8 and 4 over 8, which reduce to, well, 4 goes into both of those, 4 goes into both of those, and I get 3/2 and 1/2. And that's my 2 answers for that. You can have fractions. You can write it as 1 1/2 if you really choose to. Sorry, I didn't show that. You can write it as 1 1/2, but I can leave it as 3/2, and that's totally legit for me. Okay? All right, next page. So, the next page we're going to talk about what's called the discriminant. Now, first of all, at the very top here, let's rewrite what the quadratic formula is. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is just that part right there, b squared minus 4ac. And the discriminant kind of shows us how many solutions we have. If it is positive, in other words, if b squared minus 4ac is greater than 0, okay? So like on the other page, I could show you, go back to here, like when it was 49, like when it was 28, like when it was 16, and so on. So it's positive. Then we had 2 solutions, and that's what this is, 2 real roots. Roots, solutions, they all mean the same thing, okay? What that means on a graph is it kind of looks like this, where it goes through twice. Solutions are also called X-intercepts, okay? X-intercepts. We're going to touch more on this in chapter 6, but that's what it means. It goes like that, or it could even look like this. It doesn't have to be directly on both sides. It just means it has to cross the X-intercept twice, so 2 X-intercepts. Okay? If it is 0, well, that means this whole thing would go away, and I would just have a fraction, which means I only have 1. So in other words, b squared minus 4ac equals 0. I have 1 real root, and this is a double root. How does that look in a problem? It looks like, well, I'll put i.e. x minus 2 squared. It's like a double root, it shows up twice. How does that look on a graph? Well, it looks like this, where it literally bounces off. And it happens once as it comes down, and once as it goes back up. Same thing here on this side. And it only touches the graph once, so it has 1 x-intercept. Okay? Now if it's negative, b squared minus 4ac is less than 0. Well, look what happened when I1 was negative on the previous page. For number 3, when I had a negative underneath here, I ended up with an I. And what does I stand for again? I stands for imaginary number. Okay, so when it's negative, well, then we have 0 real roots. It ends up with 2 imaginaries. And I don't care which one you say, 0 roots or 2 imaginary roots. What that looks like is something like this, where it literally never goes through the x-axis at all. So 0 x-intercepts, okay? So down below, all it wants you to do is to determine the discriminant. You don't have to use the entire quadratic formula. It just wants you to tell me how many solutions there are, okay? The type and number of solutions. So 2 real roots, 1 real root, or 0 real roots / 2 imaginary roots, okay? So again, I know what A is 1, B is 6, C is 8, so I'm just going to literally plug it into b squared minus 4ac, and that's all you have to do for this discriminant stuff. Well, 6 squared minus 4 times 1 times 8 is 36 minus 32, so I get 4. I'm not worried about taking the square root of it. All I want to know is that this is positive. And if it's positive, based on what we set up above, it has 2 real solutions, or 2 real roots. They all mean the same thing, okay? What I want you to do is go ahead and try 6, 7, and 8. Just simply plug in your a, b, and c into b squared minus 4ac. Press pause now, try that out, come back and check. Make sure again it always has to equal 0 before I use it. I've got my b now is 6 squared minus 4 times 1 times 10. 36 minus 40 is negative 4. So 2 imaginary roots. And then the last one is already equal to 0, so I got negative 4 squared minus 4 times 1 times negative 6, which is 16. Remember, again, that's always positive. Minus 4 times that is negative 24. Again, that zip-zaps to give me a positive 40. So I'm just like the first problem, for 2 real solutions. Okay? And that's it. Okay? Your homework is going to be on Google Classroom, because I'm not 100% sure that we need to do all 12 of these. Well, you're for sure going to end up doing 9 through 12, I can tell you that. But check Classroom to make sure what the assignment is. I'm not sure what Mr. Borg is going to want to do here, but I'm sure you're not going to have to do all 8 of these. Check Google Classroom. Otherwise, to be safe, you could just do 1 through 12. Have a good day.